All right, here we go. Good evening, everybody. My name is Brian McCullough. Our regular meeting chair, Bill Wagstaff, is in Halifax right now. He couldn't get back in time for the meeting. So we've got an interesting lineup here tonight. So we'll go up to right away to our What's What tonight. Regular slot of Tim Cole with Ottawa Skies, just to let us know what's happening astronomically speaking for the next month. Sylvie Letourneau with her 10-minute astronomy news. Chuck O'Dale's with some interesting crater identification slides. Rob Dick with a mysterious presentation on how we see the stars. Okay, we'll have a break. We've got some door prizes here, a few door prizes for the break. Rob Alexander, Mike Mogadam will be talking about the CARP star parties that have been happening and other things that will be coming up. And I and Tim Cole will be doing a presentation on a lunar presentation, Sunrise at Sinus Iridum, and our regular section with observations and then announcements at the end. Are there any, does anybody have any comments on any observations they might have made over the past while since the last meeting? Anything?
Yeah, I got one.
Yes.
Just looking at Sinus Iridum about a week and a half ago, just funny, yeah, as a topic.
Yeah.
So what's up with that? Is that a cosmic alignment or something?
Well, the two of us were working on Sinus Iridum. Yeah, maybe that's probably what it was. Anybody else lay eyes on anything interesting there, other than what we'll have in the observation segment?
I looked up every night for the last 4 nights, and I did not see the aurora.
Right. Now, there had been talk that there was this huge coronal mass ejection that got belched off the sun and was heading earthward, but all reports I know from southwestern Ontario, right across eastern Ontario, nothing. Because normally if you get a CME, coronal mass ejection, coming from the sun, it interacts with the magnetosphere of the Earth, and we get the aurora, but so far, nothing. Has anybody seen any aurora?
Well, they saw it in Quebec, Wisconsin, Iowa, Saskatchewan, Alberta, and a couple places in Ontario did report it.
Oh, okay. Okay.
As far as Wisconsin.
As far as Wisconsin.
On the gallery, someone in Wisconsin actually got a
In Wisconsin, yeah. All right. All right. So just before we get started, can you check your cell phones, Blackberries, and everything, please, and put your phasers on stun, please, so we don't have any ringing telephones during the meeting? All right. And away we go with Tim Cole. One first. Go ahead. Here we go. Just to draw your attention, just received a copy of Sky News, the next edition of Sky News in the mail today, as many people probably did. And in the photography segment, one of our astrophotographers, Sanjeev, got an honorable mention for his shot of the Sagittarius region looking toward the center of the Milky Way galaxy. Yeah. All right, and I think we're ready to roll with Tim.
Okay, go around. Yeah, well, didn't want to bump into Brian. Hello.
There we go, it's better. Okay, here we are for August. Yeah, it's happening earlier and earlier. We're dominated this month by the summer triangle, which I didn't draw on. Naughty, naughty boy. So here we have the infamous summer triangle. We've got Dennet and Vega. And somewhere down here, yes, there we go. We've got Altair with the training wheels on either side. At least that's how you can recognize it. And I'll be taking a little look at Hercules a little later on. We still have a fair assortment of planets, and in fact it's getting a little better. And yeah, I still have Pluto there. Sorry, the IAU will probably get mad at us, but Pluto's still there. Mercury, yep, you've got your chance near sunset. It's always a little tricky because it's fairly low, but don't believe the nonsense about being monstrously difficult to find. It's not, it just tends to hide behind houses and stuff. Trying to break in after dinner, I don't know, I suppose. Venus, excellent chance for Venus. Of course, Venus is kind of underwhelming. Wow, look at Venus, it's a big white dot. Anyway, the fun part with Venus is looking at it over several days and several weeks and watching the phase change. And as we'll see a little later, it's also handy for finding other stuff. Mars is still hanging in there, but that's even more underwhelming than Venus. At least Venus is bright. Mars isn't. Anyway, Jupiter, oh man, what can you say about Jupiter? That's just the obvious, wonderful one. And Saturn, of course, if you can catch it early enough, we still got it. Uranus is popping out again, and since it's near Jupiter, it's fairly easy to track down. And we're going to be giving you an opportunity to think about Neptune. And Pluto, if you can find it in the brilliant muck of Sagittarius, well, good luck. Besides, who cares about Pluto anyway? It's not a planet. Dwarf planet or Plutoid or something. Anyway, never mind. Plutoid, I don't know. It sounds like you need preparation H for it, but at any rate, never mind. Preparation P. Yes, never mind. Never mind. We're not going there. August 13th, Moon and 3 planets. Is there anything astronomically wonderful about this? No, but it's cool. It's pretty. And it's a crack at faint wee Mars and still gorgeous Saturn. And of course, a very young Moon. Lots of fun. At the end of the month, we have Venus and Spica, and I always like that kind of alignment, that kind of juxtaposition of two really bright things together like that. It's always just a cool thing. And the challenge for that will be seeing if you can pick out Mars inside your binocular frame field of view, which we're showing you here, typical field of views for a set of 10 by 50s. Set of 10 by 50 binoculars. So that'll be a good challenge, see if you can pick Mars out of it. And I probably won't be able to, but then again, I can't see where the hoot anyway. Jupiter and Uranus, the only real problem is it's a bit low in the sky until you're up fairly late, but of course we're astronomers and we don't sleep. We're up there just underneath Pegasus. Jupiter, of course, is so easy to find at night. It is fiercely bright red at the moment. And you've got Uranus fairly close to it, so if you just hunt around, you can probably find it without too much difficulty, even with a pair of binoculars if you've got a reasonable sky. Of course, if you're cheating and using go-tos, it's a more so to ghetto, but never mind. Now, tracking down Neptune, that's a little nastier. One of the things that can help you is finding Jupiter, and you can sort of guesstimate where the ecliptic is and try to work your way down to the nearly invisible Capricornus. So this is going to actually be a little bit of a fun exercise. You can see we don't have a lot of movement. There is some over the month. It's drifting its way into Capricornus, but it's going to be hanging out there in a fairly nondescript chunk of sky. So this should be kind of amusing to find. And then the fun part will be arguing over what the color is, because there's tremendous argument over what color Neptune is. It always looks kind of gray to me, but I've heard people say, well, it's actually blue. Oh, really? Okay. Whatever you say. Walk away slowly. Anyway, never mind. Ceres is another fun one. Ceres is actually normally a reasonably easy asteroid, planetoid, minor solar system, never mind, dwarf planet, something like that anyway. Except right at the moment, it's a little bit challenging because it's down in the really bright Milky Way regions. So this should be also an interesting exercise. You can see we've got a fair bit of motion over the month. Now, oh, back up, yes. Our solar system challenges. This is what we've come up with. We didn't come up with deep sky challenges because basically we didn't have any. But so we threw you a near sky challenge. Track down Neptune and Ceres. These are toughies because of where they are in the sky. Well, at least I think they're toughies, but you know, your mileage may vary. Okay, so give it a shot. See what you can try. See what you can track down for yourself. And this should be kind of amusing and fun and interesting. And there's tremendous history behind these, which I could babble on for ages about, which you all know. So do check out some of the history because it's quite fascinating. Some of the history behind the discovery of Neptune and Ceres. Now, backyard deep sky. I call it M92, the other Hercules cluster. If this were any place else but not near M13, M92 would be considered a pretty snazzy globular cluster. But because it's got this absolutely knockdown gorgeous M13, everybody forgets about poor old M92, and there aren't too many super bright stars near there. But it's fairly easy. Once you've got M13, you can pretty much follow your way up from the breastplate of Hercules and track down M92, and it's a fun one. In a way, that picture's a little, I wish I picked a different one because that kind of suggests it's as big as bright as M13. It isn't. It's a little small, but it's quite a nice little globular. And if it weren't next to such a big, gorgeous one, we'd probably be considering it as a lot cooler than it is. I left M57, the ring up there, just, well, because it's up there, and you'll probably want to take a peek at it if you're going to wander by M13. We've got the Perseids coming up this month, and for a miracle, there's a virtually new moon at the time, so you have actually a decent opportunity to see it. This is, I can't think of the word, I can't get the word out. Anyway, it's, oh, speak.
Time exposure of the radio?
Time exposure, but yeah, it's also
Composite.
thank you. Yes, composite video. No, but God, composite photograph. Anyway, and with this you can actually see where the radiant is, and that's really cool. I think it's really cool anyway. So Perseids, it's actually pretty straightforward. 12th to the 13th. New moon's actually on the 10th, but and you can probably pick up some Perseid meteors around then. It's a fairly flat peak. It's not this sort of kind of whoa, boom, evening of the peak is nothing. It goes on for quite a bit before and after. In fact, the actual peak for the Perseids is at about 8 p.m., so we're going to miss the real peak of it. But even so, around midnight will probably be your best crack at finding things. Why the heck do we call it a Perseid? Because it appears that all the meteors associated with that shower are coming from a point right near the constellation of Perseus. And all that's happening is the debris left behind by a comet called Swift-Tuttle is forming a nice little debris trail, and when the Earth plows through it every year, we happen to be facing in the direction of Perseus. So it gives us the parallel, oh man, I can't speak tonight. That gives us the, thank you, the convergence effect. Basically the effect of driving into a snowstorm. Yeah, I'll tap dance later. And this is why we have this illusion of everything coming from Perseus. It's not, it's a trick of perspective. That was the word I wanted. And, you know, it's still kind of fun to be able to track these things down. Now here's the trick with it. This is what's making your typical meteor. This is not making any one of Chuck's big holes in the ground. This is pretty much what you've got for meteor dust. Now, a few suggestions for the meteor watching in general. Try to look above the horizon so you can get away from the globe. Now, don't look towards the radiant. I notice a lot of people have tried that. You know, oh, it's a Perseid, you gotta look towards Perseus. Now, that's where everything's coming from. So if you're gonna look at that and just stare at the radiant, you're gonna miss a lot of stuff. So try to look away from it. One fellow I ran into suggested 40 degrees. You can argue with me about that because, heck, I don't know. But basically, don't look at the radiant. Tonight, this time around, where we don't have a very bright moon, it'll be setting early, the deepest, darkest area you can find will do you the best. So just try to, it's worth a trip. Even if it isn't an opportunity for you to go out, do try to find the darkest you can, even if it's a dark chunk of your backyard, anything to cut down that light. If it's clear, it'll be cold. Get yourself a lawn chair, settle yourself in. I say a sleeping bag, and I mean it, because when you're sitting there idle, it gets flippin' cold. Hot drinks, light snacks, binoculars to observe trails. I'll have some people who will hit me over the head with those binoculars because we'll keep insisting, don't use binoculars, it's a full sky without it. But it's kind of cool if you've got trails. However, don't bother with a telescope. You can try photography, and the classic method is put it next to your armchair and aim it up in the sky and just leave the thing on bulb. If you're using a DSLR, which is particularly mungy on batteries, you might want to take a portable power supply with you and power the camera without running your batteries flat, because I've had that happen to me a few times. 5-minute exposure tends to work for me. I usually get a couple, and I stink at astrophotography, so if I can get a couple of meteors, you definitely can. And here is the meteor. Oh, no.
No, we don't have.
Oh, yes, here we go. Wasn't this cool? Was this today, Brad?
2 days ago.
2 days ago. Yeah, can you imagine this in the Globe and Mail, a meteor shower calendar?
Full page.
Wow.
It was a full page ad.
Full page ad in the Globe.
On the back page of a section, but you can scroll. Can you scroll down through that, Chris?
Yeah, can you do that, Chris? I don't know how to do that here. Yes, make a wish. Now, I'm wondering if a meteor shower gives you more opportunities to get this. At 150 meteors per hour, that would be you have 150 chances every hour to win to get your spider.
That's the door prize for the most meteors on one exposure.
There you go.
Okay, thanks a lot, Tim. Thank you very much. All right, and just while I'm here right now, I failed to mention Chris Tarrant at the controls here. So Chris does a lot of work putting the program together for us. Taking people's presentations, some of the last minute things. So it's a lot of fun actually working with him to do the final steps. Are you ready to roll? Cliff? You ready?
Okay. Good evening, everyone. So, in the news today, the first is not the news. How does that
Want us
work?
to advance the slides for you?
Yeah, no, thank you. This is a small announcement. We, some people on the email list have received an email about this course that's happening in London at the beginning of September on planetary science. If you haven't had the email or you haven't had a chance to look at it and you want to see, I have a few copies of the description of the course and some more information about it, including prices and whatnot. Also, if some people are going, it would be nice to tell perhaps Brian or myself. So in the news, rabbit holes on the moon. Back in the 60s, before I was born, or before the website said before humans went on the moon. Actually, I was born when men went on the moon, but I wasn't born when they started seeing those tunnels on the surface of the moon. They came from pictures that they got from the early orbiters. I have an old book here from 1970-ish, and it actually has those old pictures. And you can see the channels, but you cannot see anything that would look like this here, this hole. So from there, the scientists sort of knew that there was evidence of tunnels which the lava had flown billions of years ago. Now, like on Earth, Hawaii, for example, those lava tubes are formed when the upper layer of the lava flowing from the volcano starts to cool down, and the lava underneath continues to flow in those tubular channels. The ardent lava above insulates the lava below, and it can continue flowing for a while. Now, the tubes that are created, we knew they existed. Now, what happened is the NASA Lunar Reconnaissance Orbiter started taking pictures of what looks like a cavern or a hole to one of those tubes. So these would be like entrance to Wonderland, to those tubes. So last year, the Japanese spacecraft Kaguya, if I pronounce that correctly, took the first pictures of one of those holes, and then now, over the last month, the LRO started taking more pictures of it, and has a little more details about the hole that was found. Now, this one is on Marius Hills, and what they think now is that is about 65 meters in diameters and may extend up to 80 meters down on the ground. If I can, next. This is a picture of the area, and that picture is from Kaguya, and that's when they first saw it without all those details, but it showed the area of where it is. And from the previous picture from the 70s, you can clearly see that you don't have enough details to see those holes, but now you do. This is more what it looked like in the 70s, and this is more what we have today. And then you can clearly see that, well, it's leading somewhere. Now, so with both those pictures from Kaguya and the LRO, I'm getting like Tim. Now we believe that the idea of the lava tube is now confirmed. So these tunnels are at least intact in small segment, even after several million years. But also, we don't know if some of them are still filled with the solidified lava. So we don't know how far we can get with this if we were to go down one of those holes. So it's hard to tell with the remote instruments. So we would need to send like a probe or something down there. But we could find a lot more of those caves that you cannot see unless you have the resolution of the LRO. So that raised the questions of, well, should we follow the white rabbit? Alice found a whole new world when she went down the hole following the white rabbit. So what are we going to find in those lunar holes? Well, even if we don't find anything specific, in those lava tubes, we would be shielded from radiation. So there would be, well, and also more stable from all the thermal variation on the moon. So for example, if you are about 2 meters down the surface of the moon, the temperature would vary from about -30 Celsius to -40 Celsius. That may not be really warm, but at least it's better than on the surface if you're close to the equator, and over one lunar day, the temperature varies from -150 Celsius to +100 Celsius. So that could be interesting for future lunar stations, or I'll suggest to use them for long-term storage. Store whatever you want in there for a few billion years. It seems to hold up pretty good.
Or the gift shop. Hey, or the gift shop.
Well, they were on the website. They were talking about the lunar Hilton, you know, for a vacation.
Yeah.
Tim Hortons, yeah. So.
Why don't you illuminate the hole with your laser beam and so we can see down inside?
Yes. I cannot be that stable.
Oh, okay.
Funny. So, and now I'm gonna get, that's gonna get interesting. The most massive star. So how massive can a star be? Well, the known limits are right now, or were, I should say, the smallest stars are limited to about 80 times the size of Jupiter's mass, and below which they're fail stars or brown dwarfs. But on the other side of the scale, the most massive stars so far were about 150 solar masses for their birth masses. So with what I'm going to talk about tonight, this limit is raised by about a factor 2 to 300 solar masses. So what they looked at is in a region they found a star which they named R136A1, that's a mouthful, and it would be the most massive star ever found with a current mass of about 265 suns. That's its current mass. At its birth, it would have been about 320 times the mass of the sun. So, and just to give you an idea, the luminosity of it is about 10 million times greater than the sun. So they would think that this record is hard to break because it doubles the previous one. And that massive star, well, what I want to explain is because they're so big, they are powerful, they outflow, and they lose a lot of weight as they age, compared to humans who trying to put on weight when they age. My case anyway. Being a little over 1 million year old, which I would just call A1 instead of R136A1. A1 is a middle-aged star, and it's lost already 1/5 of its initial mass. That's why it's down to 265 times the sun. But through the models, they think it was 320 times the mass of the sun. So that was done by a team of astronomers in the UK. They were using two things. They're using the European Southern Observatory, the ESO, the Very Large Telescope, the VLT, and lots of letters here, and the NASA Hubble Telescope as well. And they've been looking at two young clusters of stars, that RMC136A, which has a lot of young, massive hot stars, and that is about 165,000 light years away. And also they did look at NCG 3603, and they have found a few stars that are pretty big in there as well, but the 136A1 is by far the biggest. So this team is finding several stars with the surface temperature that's more than 7 times hotter than the sun. that are 10 times larger, several million times brighter. And using those models, most of the stars that they have found, or the big ones that they have found, were born with masses of over 150 times the sun. So over that limit that we previously knew. And that's where I tried to, and this is the only picture I have of the region, and it never said anywhere where is that A1 star in there, but I can see that some of the biggest ones are probably those ones that they're talking about in the article that are over 150 times the mass of the sun, or they were actually when they were born. Paul, would you want? Paul seems to know.
I saw that on the it was on the ESO, you know, the European Southern. It's the one on the right, that right one right there. Yeah, that's the one. That's
It's in there.
It's in there.
Inside the cluster itself?
Yeah, yeah.
Okay.
That's where
Oh.
that's where it is. That's where it showed.
See, I can. Yeah, okay, in
The
there.
right one right in the center of the cluster. There's about 20 stars there, so that it's the brightest one.
Mm-hmm. And that's one of the problems, is it's so, like it says that A1 alone energizes its surrounding by a factor of 50 compared to the Orion Nebula cluster. So it's so bright, it's just hard to observe. So the heavyweight stars are rare, puzzling, forming within those densiest star cluster, and they're short-lived and they have powerful winds. So they do need that resolving power of the Very Large Telescope to be able to see the individual massive stars. Now, the other thing is the stars that we know now that are between 8 and 150 times the solar mass, they explode at the end of their lives, and they turn into supernova and leaving, exotic neutron star or black hole behind. Now, the stars that are between 150 and 300 solar masses, they're speculating now that they could lead to exceptionally bright supernova, and we don't know because we haven't observed one yet, and they could be completely blown. They could completely blow themselves apart, leaving nothing behind, and dispersing clouds of up to 10 times the solar mass in iron around them. But that we won't know. They did mention that there's a few candidates of massive stars to check in the coming years to see what's going to happen at the end of their lives.
How far away is this?
136 A1 is 165,000 light years away.
It's in the Large Magellanic Cloud, one of these satellite
Yeah.
galaxies of the Milky Way.
Mm-hmm. Yeah, and the other region, the NCG 3603, is only 22,000 light years away. But this one's a little farther.
Farther the better.
Okay, well, now, Brian, you sort of you sort of stole you give away my little surprise here. So I'm back with the sun. As Brian has said, the sun has been doing some cute stuff lately. So the sun's activity level is going through cycles of about 100 years on average. The last solar maximum occurred in 2001, so we were right now in sort of a low. But with this eruption that happened on August 1st, and what I'm about to show you is one of the first signs that the sun is waking up from its vacation. So the sun's surface erupted and blasted tons of plasma into space, and we have video. Is that?
Yep.
Oh, showtime. Do I have to do something? Or?
It's on.
Oh. So on this first one, you have to look at this area carefully. You won't see it as well as the other ones. Do we do it another time?
I'll do it again.
Just a couple seconds. I'm probably over time already. Where's the fork?
Yeah, we'll just have
Now this is supposed to be totally disconnected from what happened. Now can we show the next one, which is a little more explicit in the dark? I think you'll see.
Is that something else?
No, it's the same thing.
Yeah, neat.
Yeah. So, as Brian said, the plasma was heading our way and should have created the spectacular Northern Lights on August 4th, but we've missed it. It seems only Norway got to see it. And the last one, which is my favorite, for a second, but
That's one of Tim's retinal scans.
So if it's going off to the side like that, how can it be coming towards Earth?
That side happened to be towards her.
yeah, well, those videos are not taken from Earth. Sorry, I wasn't very specific. Those are taken from the Solar Dynamic Observatory, which I presented a bit on it back in May. So that's in the same line. And I think that's it. Oh, no, there's something else. That is not part of my presentation, but Chris found that there are some apps of this for the iPhone, and that's why I put that in there, so I would see this.
Anything to add to that, Chris?
Really nothing, it's self-explanatory. There are brand new apps introduced by NASA, specifically highlighting the sun from the stereo mission and showing you daily what's happening on the sun.
Good stuff. All right.
The sun on the go. Thank you.
Okay. There you go. Okay.
I don't know how to turn this
Okay,
off.
Mr. Sylvie.
Thanks.
Here, I'll give you a little.
So I know
What is
where
this
to go.
book? What is it?
That's the 1970 pictures
I'm gonna-
of the lunar surface.
I'm gonna have to see your book for sure.
Yeah, you come and see it
Okay.
after.
Okay, merci, Sylvie.
I'm supposed
All
to
right.
jump.
Chuck. Do you want the hand mic or
I'll do
this guy here?
Yeah, this was a one found on Google Earth, believe it or not. Somebody suggested it, and a few geologists went and looked at it, and lo and behold, yes, it is a crater, which is a great segue into my talk tonight. I'm going to kind of give you some hints on what to look for if you're looking for a meteorite crater. When you're tromping through the bush and you see something strange, hey, you just might find a crater. And if it is, you'll be famous. But as your coordinator of meteorite craters, I'm going to give you some news on what happened in the solar system in the last little while. This one on the moon is a brand new crater compared to the, let's see if we get this right. Whoa, what happened? Yeah, there we go. Oh, there it is. Okay, I pushed the wrong button. Apollo 15 picture and just recent, 2009. So the moon is still being peppered. Mars got zapped just a little while ago. And this is a real weird one. I want to show it to you, not that it's a new one or not, but here's a crater within a crater. Now, what's the chances of a impact inside a crater? You know, this is on Mars, and the geologists are still mulling over this because this one looks fresher, but there's no ejecta, it seems, from it. So it could be a collapse within the center part of the crater or not. So next time I fly out there, I'll take a look at it.
Ask Rolf to do a better image.
Yeah, yeah, Rolf, let's get in there. But this is a real weird one. But the chances of a crater within a crater is, well... And just to show that we're still in the shooting gallery, Jupiter just a little while ago got hit as well. So it's happening. Peter Saravallo, are you here tonight? In the GA in New Brunswick, we had an excellent presentation on meteorite craters by a guy from University of New Brunswick. I can't remember his name.
Was it Paul Gray who did that? Was it Paul Gray?
No, it wasn't. Anyway, his final part of the presentation was what can we do to prevent these things from hitting us and so on. And essentially it's worldwide cooperation. And Peter came up with the quote of the whole meeting saying, well, looks like we're toast. Because it's not a case of if it's going to happen, it's I guess it's when. So the dinosaurs didn't have a space program. We better get bucking on here. Anyway, I can't remember why I put that in there, but I love it anyway. These two craters, they're right by the Apollo 11 landing site, but looking at those through the telescope, you'll get a good appreciation of what crater sizes look on our planet, because they're the exact same size and orientation of the Clearwater craters in northern Quebec. These guys right there. And this is just a little history, 1950s. This is a very new science, crater studies. And this is pretty well what we knew about craters in the 1950s. And 20 years later, we've got that. This is just in Canada. And now there's over 250 craters known on this planet. And what I like to say is within a day's driving distance of where you're sitting right now, there are 10 major meteorite craters you could visit. Just give you something to think about. So, how do we identify a crater? Well, first thing, Eric and I went up and took a look at this guy. And circular. Well, the one they found on Google Earth, the one in Egypt that I told you about, was a circular object they found, and they investigated it, and yes, it is a crater. And this is the Chubb crater up, or the New Quebec Pingulate crater up in northern Quebec. Brand new, 60 million years old. And Eric and I camped there, walked up here, and explored right around this guy. That was quite the trip. Hey, Eric.
Where did you land?
Actually, there's a park here now, and there's a small strip right there. I didn't land myself. I came in with a twin otter. A couple of girls, they were late 20s, I'll tell you, and these girls knew how to pilot that airplane.
They sure did.
And they 500-foot long runway, and they got her in and out. No problem at all.
An aircraft carrier.
Yeah, exactly. It was cool. But anyway, the airport's right over there, and it's a good, 2-3 kilometer walk up here, and it's not an easy walk either. So, circular. Well, here's two circular objects. Which one is an impact? One is, one isn't. Let's figure this out. Well, what do we look for? Well, first of all, we look for circular objects, right? And we'll go to Manicouagan, and yes, it's circular. Wow, and I love that picture. Yeah, I got a good thermal on that one to get on that picture. I just want to mention, if you ever look at the Manicouagan crater, Eric and I explored in this little area here. A lot of good sites to see, we'll show you in a second. But if you notice here, look at this circular object. And I mentioned that to the professor at the University of New Brunswick, and he said, maybe. Nobody's really explored it, so it's a case of, well, it might be and it might not be. So Eric and I are going to go there someday, and we'll be famous if we find. But what are we going to look for? Well, on the way to Manicouagan, there's shattered rock. Yeah, it could be. This is about 60 kilometers away from this point 0 at Manicouagan. And, you know, we've all driven through the Canadian Shield and saw the rock cuts of the solid rock. Well, this is what it looks like when it got zapped by a meteorite, a large one. Impact breccia, this is impact melt around here. This here is the country rock that got blasted out of the hole and then plop, plop, plop back into the lava. Yeah, that could be a sign of a meteorite crater, but naturalistic around volcanoes could be the same thing. More breccia, yeah, getting closer. And I just wanted to bring this up. This is a good tourist shot. Here's Chuck peddling his brains out and Eric taking pictures all the time. But anyway, we're heading for this cliff in the background is an impact melt picture. And this was just a good tourist picture. And I read a paper later that showed a real cool anomaly on that cliff. And this is a picture from Eric right there. That is a large piece of country rock. Now just let me get my statistics. What you're looking at here is impact melt. This used to be about 2 kilometers thick at one time. Now this is 240 million years ago, so there's been a few years of erosion. But here we go. This rock basically got ballistically blasted out of the crater. You got all the impact melt from the impact, and this big rock goes plop into the lava, and it starts to sink. Where are we here? Okay. The rock is 3 grams per cubic centimeter more dense than the melt. So you have a constant rate of sinking. So the paper was dedicated to the study of, the rate of sink of this rock, which would give a rate of the quenching of the impact melt. It was a fascinating paper, lots of mathematical equations on it. I'm sure everybody would love it. But anyway, this was a real unique shot, and Eric and I were just taking random pictures, and it was just awesome. We got this one. And this is a pure cliff of impact melt. Yes, this could be, if you see a cliff like this and it's impact melt, if you identify it, you might have a meteorite crater. But the main point of this whole talk is how you and I, looking at rocks, can identify it. Well, I took this picture, and I looked around, and I looked down, and what did I see? A shatter cone. Now, this is something that you can see with your eyeball that is very unique to a very high-pressure explosion, a nuclear explosion or an impact. 240 million years ago, nuclear explosion. 240 million years ago, a large impact. Well, I'll go with the impact. So, shatter cone. I've got one here I'm going to put out. It's not a door prize. You can look at it during the break. Take a look at it during the break and study it. And if you see something like that while you're walking through the bush, you've found yourself an impact crater. This is just another tourist site from Eric and I. We were marooned on this island for 22 hours. Nice calm weather we found. And here's a canoe back here. You can see the size of the canoe relative to the waves. And that canoe was full of rocks. Yeah. We barely made it on that island. We lit a fire, dried ourselves off, and 22 hours later, in the middle of the night, it calmed down and we just hightailed it out. But we had enough food for another 5 days.
It was great.
Yeah, we would have made it. What a trip that was. Anyway, so getting back to which one is the circular one and which one isn't, let's go to Slade Island, and I'll show you another shatter cone. This here is the largest identified shatter cone on the planet, and that's me for scale. So it gives you an idea how big these guys are. So, which one is the impact structure? This one here is Lake Scutamata, just by the Bon Echo Lake. Eric and I just flew over that today. Before I go on, Bon Echo is very unique. It used to be all ocean around here, and as the ocean receded, some biology was left behind. Well, Bon Echo has a freshwater shrimp in it. It's the only one in the world, apparently, from the ocean. So it evolved into being a freshwater shrimp. And up here, this is Presqu'île in northern Quebec.
Remind him that's where Nirvana is located also.
That's right, yes. We took a picture of Nirvana for the observers later. We saw it from the air. Instead of looking from there looking up, we were up there looking down. So this is where Presqu'île is, up in northern Quebec. That is an impact site. The other one was not. Scutamata was a geological feature. Very circular, though. These are shatter cones at Presqu'île. Scale my finger, and there's a shatter cone there. This one here, an interesting story. Eric and I were paddling along Presqu'île, enjoying life. All of a sudden, this big rain shower, black cloud was coming towards us. So we paddled like heck. Well, I did. Eric was taking pictures. We got into the lee of an island and waited there. And yeah, it was quite a storm. And we were sitting there discussing life, the universe, and everything. And it rained and rained and rained. So I said, what the heck? I'm going to get out and look around. The first rock I picked up was a shatter cone. Awesome.
I was joking.
Yeah, Eric was joking.
Look, there's a shatter cone, and he looked. And
yeah.
for sure there was one.
And I picked it up. There was. So that's how you can identify a shatter cone. I'm going to leave one out here. Take a look at it at the break. If you see one in the bush, you're going to be famous. Sorry, Brian, I was as fast as I could.
Oh, no, that's good. That's good. Thank you, Chair.
Yeah, that's good. Thanks a lot, Chuck.
Okay, shatter cone right here after the break.
Okay, the non-door prize. The non-door prize. That's right. Yeah. Rob, Dick, you're up next.
how do we see the stars? We've seen a lot of pictures similar to this, though this is taken from Desktop Universe, so that's kind of cheating. But we've seen similar pictures like this which show bright stars and, now which one is it?
The right one.
The right one, right. Bright stars, dark background, good contrast, and that sort of thing. And these, what we see nowadays usually are all digital pictures. Not too many people dare bring in their old film pictures. But most of them are digital, and they've enhanced them so they look really nice. But the telescopic views are very different from this. And I see the pictures that are shown at the Observers Group meeting, and sometimes, sure, they're long 10-hour exposures, but even there's something about those pictures that differ from the guttural feel you get when you look at the sky through a telescope. I have an f4 telescope, so you end up seeing it's designed to show the nebula very well, and also the background texture of the sky itself. So this is what we get when we come to a meeting. We see something like this, and it looks somewhat artificial when I compare my view through a telescope. When people look through telescopes, I just want to get sort of a show of hands here, do people see images like this, or am I going blind?
Option B.
Oh dear, okay. Oh, how many people observe from very dark sites? A few, okay. And how many people have, say, f4 focal ratio telescopes? Good, there's not too many people that are going to argue with me. Okay, good. So, when you get a picture like this, usually you can look at the stars. They're good optics. It's a Cerebral optic, so it must be good. There's good contrast between the stars and the background, so you see the very, very faint stars. You want to enhance the contrast so that you can see these faint stars silhouetted or standing above the background somewhat. Also, you haven't taken such a long exposure, though admittedly DSLRs don't have this problem anymore, where you can get bleeding of the starlight from one pixel to its adjacent pixel, so you see lines. So some people take many short exposures and they add them together to avoid this smearing of vertical smearing of lines. So you don't have any pixel to pixel contamination. Now this is very different from how your eye works. Not sure which way to do this. This is what I see. Now, granted, I've sat at the telescope for maybe 45 minutes looking at a faint field, but this is more of the sense of the image or the field of view that I get when I look at it with my unaided eye, when I look at it with my eye through a telescope. Very, very different. And you can see some of this. Now, which one is the light?
The middle one.
The middle, good. And you can see these dark rivulets all throughout here, adding sort of like a different texture to it. And you can see, it's not that you see stars behind these stars, but you see a bit of a glow. You see a bit of a nebulosity behind these. And the nebulosity isn't there, but it's something in the visual field of your eye that you're picking up. And I think this is what, when I look through a telescope for a long time, you're very dark adapted, this is what you end up seeing, at least what I see. Now, first of all, you've got a very dark field, so your eye is able to become very, very dark adapted. And good dark adaptation means you're using your rod vision. Your rod vision, the very, very sensitive light detectors in your eye, and that would seem to be good. If you look, but they tend to be around the periphery of your field of view. Your eye lens has evolved to give you good imagery in the center. Your eye lens is actually a terrible piece of optics, but your brain's able to work on it and give you the best it can. But here, your rod vision that you're using when you're dark adapted, you're using the periphery of your vision where the correction in your eye is the worst. So, we also have an interesting effect with the rod cells, in that the cells in the center that give you a lot of the details, so you can read that fine print, read newspapers and so on. They're individual cells connected to neurons that send the signal back to your brain. But the rods are so sensitive that if that was the case, then what would happen would be your eye would be, or your brain be flooded with signals because of the misfiring of the rods. Because they're so sensitive, a little kick of thermal noise would end up sending a signal back to your brain. So it actually bundled together on the order of 10 or so for each neuron back. And there's a bit of diplomacy going on between each rod cell to say whether or not they've actually detected something or not. So that right away blurs the image somewhat, because instead of getting a single cell signal sent back, you're now getting a bundle. So the stars themselves are bloated. Now, the fainter stars, the ones at the threshold of your vision, they're also triggering rod cells. So the rod cells tend to start firing, even though you don't really see the light, the very, very faint starlight, it'll still trigger your rods to fire. And so this gives a bit of this glow. Some of the cells, for example, some of the stars, if we look at here, for example, oh, say up around here, it looks like a little tiny, well, it's a non-cluster, but there's a bit of a glow behind it. And that's because this starlight is affecting the rod cells to the side, and even the bundles of rod cells, as your brain tries to do an image processing trick to improve the image somewhat. And I also mentioned the very poor quality of your eye lens, causing the aberrations in that will take the brighter starlight and blur it. And so what we end up seeing here is when you see the starlight here, between the rivulets of stars, you actually see a dark area. And that's because this starlight here is smeared somewhat, giving you a sense of nebulosity around that grouping of stars. Interesting effect. At least this is what I see. But since you people don't have an F4 telescope and you go to a dark site, you don't have any comment in this. So here's a comparison of the two. When I'm observing from the city, well, granted, I see a very bright background because of the light pollution, and I don't see any of this little nebulosity effect when I'm in the city. But this is what you'd see, say, with a telescope, with a digital camera. This is what you see with your eye on a very dark site when you're well dark adapted. So when you go to look through a telescope, try to compare what you're actually seeing, especially if you're able to get out to a dark site at, say, a public star night, or out to FLO, or if you go to Starfest, or you go somewhere else where there's a dark site. Try to let your eye get dark adapted, put the camera away, and just stare into the eyepiece, especially if it's a fast telescope that will show you a lot of these very, very faint features, and see if your eye shows that or not. If not, come back and tell me. Because it doesn't sound like anybody's got an opinion. Well, there's a few people with an opinion, like Glenn and so on. Yes, Glenn?
Well, the F ratio of the telescope has nothing to do with it, because it's the exit pupil at the eyepiece,
yes,
which determines the image brightness. So if you had a long F ratio telescope, you'd just use a much longer focal length eyepiece to give you a suitably large exit pupil. Yeah,
it turns out I got just a standard variety. Well, you know the setup I've got. So, but it's interesting. Glenn, I suppose a few others here might actually have the talent to be able to critique me on this. Yes, Paul.
I think it was Hubble himself, one of the most famous observers and astronomers. He said there are things that you can see that you can't photograph, and there are things that you can photograph that you can't see. And I think he's right even to this day.
Yes, we certainly see stuff in the pictures that are shown here at the meetings, but it's very difficult to catch. And something that prompted this presentation is that looking through the telescope and say, this doesn't look anything like the pictures I see at the meetings. So I thought I'd bring this to your attention in case perhaps you can see the same sort of thing, or not see the same sort of thing.
Rob,
yes?
Just out of curiosity, do you use any type of nebular filtering or broadband filtering when you do your visual observing?
In the city. Okay, do I use filters? In the city I did the high contrast filter, which is typically used for getting rid of light pollution. Nebula filters, if I'm looking for some very small planetaries, and it's like day and night. You literally put in if you put in a filter, this is the planetary, and you put in, say, an oxygen-3 filter, which means an oxygen atom that's lost 2 electrons, and that particular wavelength is allowed to pass through the filter. Well, then all these go away, and you're left with that. It's kind of magic. And so these filters really do work, but you do need some extra light. And you also have to have a way of holding that filter so you can flip them back and forth. I think that the flipping back and forth with the filter, without the filter, is really great. I don't like screwing them into eyepieces. I'd rather have a slide with filters on them.
You've got a couple more.
So how did you make the image?
How did I make the image? Oh, gosh. I cheated. But then again, I'm using my eyes. So in a lot of the photography I do for light pollution and things like that, I try to make the image what I see. And the one on the right is from Desktop Universe. The one on the left is the Desktop Universe that I've done a number of things to. Typically a Gaussian, a very, very large Gaussian blur, adjust the gamma, and adjusted the brightness to give that brighter appearance to it that I see in the eyepiece.
So it's simulated.
It's simulated. Because otherwise, you can't see what's in my eye, so you'll have to trust me, and that's my interpretation on a computer screen. And even then, when I look at it now, there's a different projector than what I use at home. So I would tend to darken it down a little bit more. But
Yeah, it does look too bright.
yeah. Okay.
And you've got this as well.
Okay. Okay. 45 years ago, the Ottawa Centre was very, very different from the way it is now. In fact, there seemed to be about 25 to 30% of the membership in what we called the Observers Group were actually high school students and young university students. And these people were the people that did all the grunt work and also did all the clever stuff and imaginative work. And one of them was John Conville, who was a high school student when he joined our group. And he just ended up dying about 3 weeks ago, which came as a bit of a shock because he's younger than most of us that have the gray hair now. There's a few of you in this audience that might remember John, and so the idea is just to let you know of his passing. This picture was taken circa 1970 or so, where we had our main observing site was called Quiet Site, and that's located out the west end of Ottawa. Some of you remember, what's the museum? Down the Riddle Road, the Y Camp.
Down which road?
Y Camp,
Down by the YMCA.
Yeah,
Near the solar observatory?
Rocky's Point.
Penny's Point, yeah. And if you go down to Penny's Point, you end up going down this road called Riddle Road, and you make a left down to Penny's Point. Well, if you try to make a right, you hit a locked gate. And the Quiet Site was in behind that locked gate. And it's a property from the Communication Research Council out there that we're using. And here's a picture of what it looked like. We're not supposed to touch these antennas. It was covered with antennas. And so I climbed up one of the antennas and took a picture of the site. Beautiful site. This contraption here is where we did meteor observing. In fact, most of the observing work we did were meteor observing, where you sit around and get to know people, talk, and learn. And John was one of the most intelligent people in the entire group, I can tell you. He was well above us in knowledge and technical prowess, and even his humor was a little more, you don't realize he just cracked a joke until a few moments later. So he did an awful lot of observing at Quiet Site, but he also was one of the instrumental people, no pun intended, with the building of the 16-inch telescope that we have now at Fred Lossing Observatory. And for those of you who are interested in remembering him, then the memorial service is actually going to be on Sunday, this Sunday, August 8th, at the Britannia Yacht Club. And when he left Ottawa, he went to the University of Western Ontario, where he got his degree in physics, bachelor degree in physics, and from there he disappeared to California. And in California, his career spiraled up in a number of companies, doing some rather clever and pivotal work in some of those companies developing technologies. And you might imagine he started here. In fact, there was an article written where he actually built the LED pointers. It's very difficult to point the 16-inch telescope in those days because you couldn't get your eye on the truss. So he just put in some LEDs. LEDs were new in those days. You had to put resistors in, and they're weak and so faint. And he's one of the people that put that up out of frustration.
Who are the other two on the photo?
Yep, the other two, this fellow here is, you might consider to be the chief engineer for the 16-inch telescope, Gordy Grummett. And the original sketches came from this fellow, Tom Tothill, and another fellow in the group many of you might remember is Fred Lossing. And Gordy took these Dreamland sketches and turned them into engineering drawings, and then he did the machining and the assembly and the work to make the telescope reality. So in other words, Tom Tothill and Fred Lossing, they came up with a design, and it was up to Gordy to make it happen. And of course, did a good job in making it happen. And John was one of the people in the sidelines doing a lot of working on the grinding machine and so on, actually grinding the mirror, putting in the time for that. So he's quite a prominent member in the past in the Ottawa Centre, and the fact that he deserted us for California is no reason for us to forget him. Thank you very much. Perhaps we'll see you there on Sunday.
All right, thank you very much, Rob. Just a little short announcement here just before we get going toward the break. The Galileo scope that was produced in association with the International Year of Astronomy last year is now available through the Ottawa Centre. There are a number that have been brought down this evening. Al Scott, are you taking the... Okay, so Al's doing that. And just before we go to the next one, you may have been hearing a wee voice on the side, all right? So we've got Gordon and Concepcion Webster and little Julia. Hi, Julia. She's over by the wall there, right? That's who we've been listening to. All right. So welcome to your first. I think it's your first meeting, eh? All right. So sign her up. Sign her up.
Evening, folks. I'm going to talk about the wonderful star parties that we've been having at CARP. They're taking place at the CARP Public Library, which shares the site with the Deafin Bunker. So if you know about our Cold War monument to Deaf the Chief. So you can see the observing site there is the parking lot. It's great. We got lots of flat surface, a couple levels. We sit up on the furthest south part of the parking lot there, facing towards the open fields, and folks park on the rest of the site. It's quite easy to find. It's easy to get to. We got room for lots of scopes, and it's really great. The people at the library and at the Deafin Bunker have agreed to turn out the lights for us, so it's actually quite a dark site, and it's quite accessible. So it kind of walks a very nice line for what we often encounter with sidewalk or public outreach astronomy, is that if you've got a dark site, it's somewhere that people can't get to, or if you've got lots of people, it's in a very bright site. So this spot here is actually a very nice compromise. Next, please. Here we have a couple of our members. We have a large picture of a small scope and a small picture of a large scope. Oh, there we go. Here we have closer to life size. As a matter of fact, even that is not life size. The scope on the right, telescope, is quite monstrous, and it's a wonderful piece of equipment. The one that Jeff has there is also a very nice piece of kit, but it's obviously considerably smaller. But this gives an example of the range of telescopes that we get there. This is on the south side of the lot, facing south, so you can see we look out over the field with some cows there. Next, please. Here's one of the more lavish kits that one of the guys brings. This is Bart. You can see Bart on the right there, tempting the mosquitoes with his bare legs. And he has a trailer where he carries the telescope in, and once he takes the telescope out, he's got room inside the trailer. There's a couple chairs and a desk and a table, and he has a small generator computer system with several monitors. It's a wonderful kit that he brings. I think Bart has as much fun with the equipment as he does with observing, and that's okay. And here's some more folks. These are folks we hadn't even met, and I think this is really interesting that the word of the star parties is getting out, and it's not just people coming who want to look through a telescope. A lot of times it's amateur astronomers who haven't been involved with an astronomy group at all. They hear about this and they go, well, why don't I take my scope out there? Maybe I'll learn something. And so, or maybe I'll just have fun. So these folks here were folks that we hadn't met. They're not part of the RASC or OFS. And they just came out to observe, including one fellow there in a powered chair, brought his scope and set up and joined the group, and it was great. It was just a really good time. It was a great night. Next, please.
Move on.
Oh, look, just go back one there. Here we have someone from behind. This is, I just wanted folks to have proof that Chris does do other things than sit at the computer here.
Rare shot with me without the computer.
Here's some of the contributors, participants in the day. There was a lot more. We couldn't find all the names, but there's a few of us there. And next, please. And that's it. So there's another one of those planned for tomorrow night at the same location. The forecast has been looking fabulous all week up until this afternoon. And with the perversity that only astronomers' weather can achieve, we have a little bit of cloud moving in Saturday night from 7 p.m. until midnight. Exactly the times when we would want to be there. It's a very small cloud system, though, and there's a chance it could move one side or the other. So we're going to call the go or no-go at noon tomorrow. If you're a member on the OAF's mailing list, that's probably the first place it will be announced. Unfortunately, we don't have the web address, but if you just look up in Yahoo groups for OAFS, OAFS, you'll find us, and you can just join right then, and you'll be on the mailing list. Okay. Thanks a lot, folks.
Thank you. Next slide, Chris. Hi, everyone. Thanks, Rob. And here is the 2010 Ottawa Centre Public Star Party schedule. Now, for those of you who aren't familiar with this and maybe are new to these meetings here, at our star parties, which again are in CARP at the Ottawa at the CARP branch of the Ottawa Public Library, and specifically the parking lot, amateur astronomers from our club and from other clubs, as Rob mentioned, come and set up their telescopes and share their views of the night sky and their passion for the night sky with anyone who wants to come and enjoy it. They are free events. They're open to all. We don't sell or promote anything. Maybe our passion for the night skies. But you can see that we've had a couple already. We're always, the weather really calls the shots. We've got an event scheduled for tomorrow. I haven't, I'm going to wait till probably midday tomorrow before I make the go, no-go call. As Rob said, right up to like today, things were looking just so wonderful. And we'll see. So hopefully the weather will change again, the forecast will change again, and it'll be clear right through tomorrow evening. So I'll post a go no go on the OttawaRASC.ca website, and I'll also send out emails to various groups that various email groups as well. Just one thing I wanted to let you know is that I was talking to Gary Boyle earlier, and we actually do promote these events. There's a lot of radio promotion. Gary sends promotions to, I wanted to share with you the various media outlets that we send them to. Y101, Magic 100, KISS FM, Bob FM, Hot 89.9, CBC Radio, and CFRA, as well as television, CTV, and CBC. We send announcements to letting people know about these events, and to, of course, check the website for the go, no-go in the event that clouds roll in and we don't proceed with these events. You don't need to have a telescope to attend these events. If you want to bring binoculars, that works well. If you just want to bring your, come without, that works also as well. So, oh, thank you.
That's live. There's the nasty cloud.
That's live?
Yeah, it's live, and there's our observing time.
Don't you love it, eh? I mean, it's just for like the last 3 days, it was like, I thought this is going to be the easiest call to make, and then here we go.
And look at the size of the little cloud coming over us. One little cloud. The opposite of a sucker hole.
So it's never easy. The last thing I wanted to say just before I close is that if these stargazing events are wonderful for those people who want to sort of like try before they buy a telescope. So if you're not really sure what to get and you want to see what's all out there, well, the full spectrum of equipment is usually at these events. So it's a wonderful opportunity to peek through each one of them and ask questions and see what works for you. Okay, so I hope to see you there. Thanks.
Okay. Upward and onward. All right, so here we go with the my presentation on sunrise at Sinus Iridum. All right, we'll go to the first one, please. I was out on June 21st. It was, what happens on June 21st? Summer solstice, of course. So I was out and just before sunset, and I had noticed this beautiful moon up in the sky, so I jumped into the observatory in my backyard to take a look. And then I thought, wow, this is looking very interesting. And what I was noticing was just over here, this is called Sinus Iridum. It's the Bay of Rainbows. And you have, here's a close-up of it here. And it's an old flooded crater, right? So all we see is the one wall back here to the north. And they're known as the Jura Mountains, so Montes Jura. And what I noticed was that it was just starting to be illuminated. So there's just the slightest bit being illuminated. So I grabbed my little pocket digital camera and I started firing shots for 2 hours, every 10, 15 minutes or whatever it was, through the eyepiece of the telescope. So I'll show you what I've done. And I've had technical assistance from Tim, and he's got a presentation, a tandem presentation that will go on the back end of this. It's called The Making of Sunrise at Sinus Iridum. All right, so here we've got this nice shot of the moon. All right, do we need these lights up here? Can we get these down maybe, Tim, please? All right, so that's what I was observing, and it was still daylight. I don't think the sun had, the sun hadn't even set yet. It was 8:42 p.m. So this is the area. We'll go to the next one, please. That's the area that we're looking at here. And if we go to the next shot, this is my slide from a month earlier, the previous lunation, when I spoke about this area. So just to give you a couple of locator points, we'll see in some of the images the crater Plato and the crater Bianchini just up on the rim of the Jura Mountains, which run along here. You'll see the two craters Helicon and Leverrier. And all of this is part of Mare Imbrium, the huge impact basin on the northwest quadrant of the moon. Right in here now, the Sinus Iridum, it's about 260 kilometers in diameter, and the things to watch will be Promontorium Laplace and Heraclides. Okay, let's go to the next one. So I think I've explained before about my stunning photography, right? So here we have an example. You should have seen what I gave Tim. He'll show you what I gave him to work from this. So I've got a series of 6 slides, and I'm going to walk down through them one at a time here. And you're going to see, we're just looking at the region here. Let's go to the next one, please. All right. Okay, we can see this, the sunrise or the nighttime terminator. All right, let's go to the next one. So now we can see it starting to be illuminated a bit more. And this was all happening across virtually 2 hours. We're up to 10:49 p.m., so it's about 2 hours there. And I think that's the last of the series there. We go to black. Okay, I'm going to walk you back up through it just to peel it away. We'll peel it away one at a time. So obviously my exposure settings were all over the map there. Okay, let's just, I guess it's just as easy to walk back down. And now what's happened is Tim has taken these images. You've seen the pictures. Now sit back and enjoy the movie. That's loud. Plug your ears. So I can't tell you how exciting that was to be able to go out and actually do the observation of this. The photography, in a sense, was secondary. I wanted to capture the event, but anyway, so we'll get Tim up, and he'll tell you how he produced all of this for us. Right, Tim?
Sure. The making of, yes. And interestingly enough, that little musical piece you had there is actually Vangelis, and it's called Dawn. So there you go. There's your linkage. So sunrise over this area is a really cool chunk of moon. So let's take a look at what we had going here. Brian approached me to see if I could piece together some of his stuff. Here's what we started with. Now he's taken a handheld camera and simply shot down the barrel of the eyepiece. It's technically called afocal coupling, and it's a legitimate method of astrophotography. It works surprisingly well. So this is the 6 pictures that we've culled out of it to cover the full range of his 2-hour exposure run. Once you crop them and lay them out, it's not quite as daunting as it looks. And the first thing that you're going to notice is there's a fair variation in tone and overall exposure value from picture to picture. That one's fairly obvious. The next thing you'll notice is a bit of rotation from picture to picture, and there's some slight scale variations. Now, all of those things are bog simple to solve. Unfortunately, it's a little messier than that. You can see up here in the first picture that Plato has a nice, reasonably, you can squint and make it circular. Over here, it's starting to have kind of a blocky, rectangular look. But by the time you get down here, it's got some really trapezoidal aspects to it. So there's quite a bit of change in the way the pictures are showing scale and morphological state, if you want to use a nice snazzy $3 word.
Distortion.
Not distortion. Anyway, right. Speaking of distortion, every lens is going to have some distortion, either in design or because of the angle between the lens and the target. And you'll always see that second effect if you're taking pictures of tall buildings. You'll always see that. Photoshop provides a set of standard lens correction tools, which will allow you to undo the effects of barrel and pincushion distortion and perspective in 2 axes. So that's what I've done here with one of these images. And you can see we've made sinus iridium look a little more circular. Put in a modest undistortion of barrel distortion and corrected for perspective. And that looks like it might do it, but unfortunately it isn't enough. So let's take a look and see if the problems you've got. The ideal world, you're going to be aiming your camera smack right up the eyepiece, and your optical axes are going to be absolutely coincident. Yeah, right, that's going to happen. So breaking it down, we can have transverse misalignment, where our optical axes are parallel to each other, but misaligned. And the obvious thing you're going to get there is vignetting, but it's a little worse than that, because you're going to have the maximum distortion in any lens at the edge. There's no other way to do it. So this means that our nice, interesting part can be nicely and too heavily distorted. Or you can have angular misalignment, where basically the center points are aligned, but we're tilted, and that's even nastier. We've got our hypothetical light rays going through multiple thicknesses of glass and multiple distances to the focal plane of the camera, so basically we've got a really nice nonlinear distortion all over the film plane. And when we tie those two together, that's our general purpose case. The center points aren't aligned and you're rotated. Now, you can get a lot of consistency if you use a digiscoping adapter, where we basically clamp the camera in place. And at least that way your distortion is consistent from frame to frame. But in this case, where it was handheld, our distortions are continuously changing.
Tell me about
it. Tell me about it. Now, the later versions of Photoshop have provided a fairly nice warp transformation tool, where you basically apply a set of splines over the picture, and you can warp these with the handles. And this, by the way, is not a particularly extreme distortion necessary to do the correction. This is fairly typical of what I've run into. Now, we've got to be able to align the pictures to each other, and this is where selecting features are going to come in. We're trying to take a picture of the sunset, the sunrise here, So what this means is we've got to be very careful that we're not aligning to varying, into changing light features, that we're actually aligning to geological features or selenological, if you prefer. So I haven't used all of these in every picture, but I've used these in throughout the process. The big ones, the big workhorses, are these two little eyeballs down here, Helicon and Leverrier, and Promontorium Laplace. And interestingly enough, this tiny little crater, Promontorium Laplace A, this, by the way, is a kind of a pathological crater name. This is one of the 14 features on the moon that takes, that provides crater names that is not in itself a crater. These ones here in the night region, these are really useful for trying to pin down the distinction between geological features emerging and changing light patterns. And finally, Plato and Laconomine up here, these are quite useful for just pinning down the overall scale and positioning of the pictures. There's another little function here for Montes Recti, where I'm using that to try and get some regular, get some consistency in the imaging, in light and tone from frame to frame. So here we've got a frame, two frames laid over each other in Photoshop. The top one's been made partially transparent. And you can see here we've got a fair bit of misregistration, and not too bad. You'd think we could just move it around, but take a look here. The distance between our two versions of Promontorium Laplace A and the distance between our two versions of Helicon and Leverrier are different. So what this is telling us is we've got some nonlinear distortions across the picture, so we're definitely going to have to do some warping to fix this. Now that leads to a problem where you've got inconsistent warping from picture to picture. What the heck is your reference? So what I opted on doing here was pulling out a synthetic map as the reference. This is actually taken from Lunar Map Pro, and that is actually generated for the time that Brian did the sequence. So this is already compensated for libration and parallactic angle. So this is pretty much what you'd expect to have this region looking. So the first step for me was to take every frame that I've picked and do a rough alignment to my background frame to at least make sure I've got the bulk of the transformations done. So here we have a partial registration. It's not too bad at first glance. We've got Helicon and Leverrier nicely tied up. Laplace, Promontorium Laplace A isn't too bad, but take a look up here, and Laconomine has got a terrible ghost to it. And Montes Recti, it's kind of clunky. So there's still a bit of work to be done. So here we have Photoshop's warp transformation tool in action. This is one case where you got to be a little careful, and this is where the history menu in Photoshop is incredibly useful. You can do this in stages, and this way, if you discover that you have totally fouled it up, which trust me, you will do, you haven't completely lost all your effort. So frequent saving is kind of important. Now, one of the things is you don't want to add any real noise to it, and this is a case where there's some features in Photoshop that will help you pin that down. It's really important too. You want to save this because, hey, this is Windows, and you have to consider that crashing is possible. You want to make sure that Photoshop will keep the history from save to save, and this is something that I learned the hard way several years ago, and I continually check this before I do anything. So with a few iterations here, we can get some reasonably good warpings to get them all to at least a consistent state. And here's our first crack at it, and this, I'm still sitting here in the program. You can still see the screenshot. And one nice thing is after you've redone this is it'll start with a new set of splines, and you don't have these horrendously complex splines to diddle around with, and that does make your life a little easier. Now, by the time you take a look at this, you discover that it's not as sharp as it might be. So I didn't want to do too much sharpening to it. What I ended up doing was adding some deconvolution. This is actually one of the oldest deconvolution methods out, Van Sittert, which some of the references for the processing for Lunar Orbiter and Ranger suggested was quite effective for lunar processing, and the AIP for Windows book suggested as well. And I found it worked fairly nicely. There's some nice cheap little packages now that can do this for you in Photoshop. The next thing you want to do is get rid of some of the grain so we get a nice rich field of dark, and we've taken a little bit of the green out of the planes. But I don't want to get rid of all the sharpening and all the processing I've done in the highlights. in the highland regions, so I've masked those out and only applied my grain reduction in the areas where I'm not going to be undoing all the work that I've had to do. Last step we're going to do is some histogram equalization and some adjustment for tone. This looks like a lousy histogram curve. I'm not going to claim it's a wonderful one, but it's actually not as lousy as it looks. There is actually a significant tail here, and if you pull the white point right over to the edge of this, you're going to blow out all the details. So at this point, we've got a reasonably nice picture, and now we want to make sure that we've got the lighting at least reasonably consistent from picture to picture so we can really see a proper sunrise. And what I've done here is oh nuts, I did that, didn't I? I've taken this chunk here just to the lunar east of Montes Recti and used that as a reference point to adjust the overall tone of the picture. I've really wanted to make sure I haven't overworked this because I want to make sure we're seeing the reality and not any artifacts. So now we've got our finished shots. There's still a bit of variation in color from frame to frame. One way to get around that would be to take a grayscale. I don't like that for purely aesthetic reasons. There is some color there, and I don't like killing it. What I've done here is I've taken the Photoshop equivalent of the old photographic filters that you used to use in plain old chemical darkrooms and applied some cooling filters, some warming filters in the first few exposures and some cooling filters in the last one. So now we have our frames that we can sit here and run through or produce yourself into a movie, and now we can watch the sunset. Now, obviously, we're starting as the sunrise. We're obviously starting with pictures that are not, not ideal for the purpose, but you can actually make some reasonably good stuff out of, whatever you happen to have on hand if you're fortunate. Will this stand up for anything scientific? No, it won't. This is pretty picturing. But pretty picturing itself can be very, very useful because it's showing you what is, in fact, a really, really cool thing. And that's watching sunrise over some of the most fascinating chunks of the lunar surface. So there you go, folks. You've seen Brian's effort. You've seen what I've done. I'm not claiming this is the perfect way to do it. I'm not even claiming it's a great way to do it. But it's my way of doing it, and I think we ended up with a pretty nice little result. So that's it, folks. Thank you all.
I thought I was being a scientist. Yeah, I was really embarrassed when he showed me, when he passed me over his PowerPoint to show me some of the things he had to do to this. I had no idea. I said, you're going to make me look a total idiot, but there it is. So anyway, on to the observations now. All right, so we've got 6 sets of observations. Paul, are you going to work from your chair there?
I will.
All right.
All right, this is...
Do you want a microphone?
No, I think I can speak loud enough. This is the one, HZW388. It's a very remote object. You don't often see it. It's one of these Zwicky remote groups of galaxies. You'll see in the middle, that's called, its nickname is the necklace. The brightest galaxy there is about the 14th magnitude, and the other ones are 17th and 18th magnitude. It's a very difficult object to find. I spent a lot of time. I spent more time trying to find it than I did photographing it. But it's one of those things, if you ever want something that's remote and hard to find, that's the one to see.
Okay, let's go.
I did that just recently, the other day. That's M20, NGC 6514. It's a star-forming region. It's about 6,000 light years away, and it's 15 light years across. Now, as you see, there's a very bright spot in the middle. There's a star there, an 07 star. These are extremely bright and big. This is something like Sylvie was talking about. This is one of those things, these very, very bright type of object. This is a very interesting thing. It's a younger star-forming region than what the one in Orion, the M42. This is a much younger forming region. Next, please. Now this is a planetary called 7662 the blue snowball. I find that the planetaries are the most difficult things to photograph. You have to take some of them, they're very small and very bright. So what you have to do is take a very short, I think that's only 10 seconds, like a snapshot. Because if you take a longer shot of that, the thing, you'll burn it out. And yet you got some things like the dumbbell and all these that are large that can take a longer exposure. I find the globular clusters are the easiest, open clusters second, galaxies, then planetaries, and then anything, and any nebulosity is very difficult. But this, I took that last year, and that's one of the, I found this to be a very difficult, I had to take a lot of pictures of that.
Thank you, Paul.
Thank you.
Could we get all the observation presenters maybe starting to make your way across here, please? All right. And Tom's not here. Tom, are you here? No? Okay.
Is he here?
Oh, he's here. That was just a little, one of my better shots, we'll say, Tim. Tim didn't do anything to this one. So I just got the moon and I took a couple of tries to get a bird in reasonable focus for it. This is just a filler until we can get the next slide up. Oh, it's my own again. Oh, okay. Okay, let's run it. This is my Saturn video, handheld. Yeah, I was shooting in stereo. That was the second one there. Keep your eye on the ball. I figured there might be able to grab one or two stills out of this somewhere. Like we have to catch it like in a microsecond.
Tim, can you fix this?
What?
Yeah. Yeah. Wait for it.
Sorry, I'm washing my hair.
It's still. This is still video. There it is. And I think it's going to jump up here somewhere.
Brian, what was your camera?
I'm not saying. It's just some little thing I got at Staples.
What did he drink first?
It was an emergency purchase.
My God, it's the monolith.
Yay! There we go. All right. Okay, who's next? Oh, thanks, Rolf. Just to, yeah, all right. Do you want a pointer there? There's a pointer.
What about this?
Oh, there you go.
Right, so Jupiter's getting pretty prominent, and so let's see. So what's interesting in this one is all these little black spots here, I guess.
Come on, Rolf, where's the damn movement?
The what?
Where's the planet moving? Come on!
Well, I can move on to the next picture.
Oh! It's just
I don't know
sitting
which
there,
one to
looking
print.
perfect.
Is it the one on the right?
Yeah, the one on the right.
Okay.
It doesn't even move. Where's the fun in that?
Okay, so this is obviously another time where we've got the red spot, and this is the moon Europa and its shadow.
Oh, wow.
And keep your eye on this. So this is the red spot, and then there's this other red spot here. And so this is actually just earlier this week, and I think they're getting closer together. You can see. So, and these pictures were taken about 13 minutes apart.
Wow.
And I would say, actually, looking at the letters, I don't think that projector is in focus. I think that should be a little sharper. Okay. Oh yes, and this is two of Jupiter's moons, the two largest ones, obviously, Ganymede and Io.
Io is really yellow.
Detailed too.
Cool.
How true is the color in that?
Pretty true.
Probably not bad. That looks right for Io.
Yeah, Io is definitely yellow,
Yeah.
covered with sulfur. Ganymede is more or less gray, but it's got some kind of colored areas in it.
Yeah, that's cool.
Now the problem is that Ganymede, I wanted to get like a whole sequence and get it rotating, but then looked it up, the rotation period is 7 days, so it's going to take a long time to get any kind of significant movement on those features.
How about Io?
Okay, so here is, anybody see this?
Yes.
You can see 4 planets. Again, I think we got to work on the focus of that projector because those are Those are not very sharp.
You just type fuzzy.
Can everybody see them there? Saturn up top? Mars?
So there's Mars, Saturn, Venus, of course. Now Mercury is going to be very difficult to see. It's down here. That's why we've got this effect here where, you know, you can see that if you're in the city or something, you know, trees, you can probably see them above the trees, but then you really got to go out where you've got a pretty flat horizon to see Mercury. So let's see. So it's in there. So we're going to zoom in on this, on the same picture there, and there. Well, I can barely see it there.
Yeah, it's there.
Yeah, right there. Oh, there. How'd you do that?
It's like magic.
Okay.
All right.
And yeah, again, I mean, this should be much sharper. How far back can you see that? How far back can you see Mercury? Is it about the middle, I guess?
I think it's just your off axis there.
That's part of it, and it's also optimized for in the floor, not on the stage.
Yeah.
All right.
Okay, I think that's it, eh?
Okay.
Okay.
Thank you, Ralph. Gary?
Great, thanks. Thank you. Well, 7 nights or 7 days ago or 7 nights ago, whatever you have, we had a great long weekend, other than being away from work. But 3 excellent nights. I rolled the observatory roof at 4:20, 2:30, and 2:30. So it was a lot of great nights. And to photograph the moon and planets, well, Ralph has twofold. He has a better telescope than I have for planetary, but also less turbulence in the country. Although I did shoot the moon and Jupiter at around 2:30, 3 o'clock when it was high in the sky. And I noticed around that time also the turbulence, the city tends to quiet down a bit. So instead of, you know, the boiling like this, it tends just to flutter a bit. So turbulence is not too bad. So here we have is Berg. Berg is Rima Berg. And hop in any time, Brian, if you want.
Yep,
and this is the crater Berg. But again, just the great details. I had a lot of good data. Yeah. And just a test, Brian, this is?
McDonald's.
McDonald's.
Aristoteles? Yeah.
That's Burger, not
Burger King. And Copernicus, what I liked about Copernicus is, of course, you get the multi-layer structure. It's something like Roman Colosseum looking straight down with the impacts in the middle, but just the ray structure, just the eject over here, and the various tinges of gray. Sorry? No, this is taken with a TU-Cam webcam. So it's about the best 150 of about 900 frames that you stack together. It's great software. It's free software using Registax 5.
Hey, Gary?
Yes.
Just give you perspective, that shot of Manicouagan I showed earlier
Right.
would fit exactly in the center of that. The edge of the moat would just be around the crater rim.
Really?
The other side.
Excellent. And next is crater, how do you pronounce it?
Cyrillus.
Cyrillus, that's the one right here. Wow. Wow.
Chris, maybe back in
Yeah,
there?
no, I got it here. Yeah,
Okay.
got the wrong one. Yeah, yeah. Cyrillus is here in the middle. Again, gray teal. And still, you can have the best lunar imagery, but through the eyepiece of a telescope, just like what we were, like Rob was mentioning about star fields, whatever, through the telescope has no justification. You really have to be at the eyepiece, look at the moon, planets to really appreciate it.
Yeah. Okay, good.
And you do. Yep. Boy, how do you pronounce this one?
Long Montanus.
Montanus. Yeah. Again, a lot of nice detail on the crater floor.
That's a good shot there, yeah.
Yeah. So I had a lot. So it was good steady seeing around 2:30, 3 o'clock in the morning.
Down on the south? Yeah.
Yeah, in the southern part of the lunar fig. And here we have is, wow, I keep doing that.
No, the button's bouncy as all get
Yeah, okay. Sorry about that, folks. Here's Posadamus. And this nice little rill over here. I'm not sure what this one's called. But this little guy in the middle is actually called Very. And Very is only 5 kilometers wide. And the moon at the time when I was photographing was 403,000 kilometers away from the Earth.
Yeah. So this is in the Sea of Serenity. This is actually, it's not a rill, it's a what they call a dorsa. So it's a wrinkle ridge.
Dorsa. Yeah, so yeah, great.
Dorsa is the plural. Dorsum.
And lastly, Jupiter, closing off the show. And I believe that was Io down here.
Oh, good, yeah.
Great. Now they gave the rest of the show away. Thanks, folks, for coming. Drive safely.
Okay. Thank you.
Good stuff. Brian, is there a light here?
A light? Yep.
Thank you. I was out with Paul Shepard observing one night at about midnight, and he was trying to see this NGC 6818. It's one of the NGC finest, and he's trying to do the bunch of them. And we were having trouble finding it. We'd see the star pattern, or he would. We're looking through an 8-inch Newtonian, and eventually we blinked it with an O3 that somebody, an O2 filter. Somebody here mentioned that. It's kind of a greeny filter, and it shows it up. All the stars go dim except for this. So after he'd finished, I took a picture of it just to see what it really looked like, because I really couldn't see it. It looks like a white spot. It's very, very interesting when you see it in color. We thought that right below this, there's a galaxy, and we thought, well, we'll just confirm that by going to the galaxy, and the galaxy is this one right here. So we'd go down to the galaxy, nothing. Go back up, we'd see the planet or the galaxy. We could not see the galaxy. I looked it up a little later, found out that you need a 15-inch telescope to see this. It's very, very faint, and it's really, really close. It's only 1.5 or 1.6 million light years away. When you consider Andromeda being, 2.5, it's a lot closer than that. It's part of our local group. And there's a couple of things about this that were pointed out to me by other people. There's this thing called the bubble up here, and it's a hydrogen 2 area. Now, I took this all in one night, and it's probably about 3/4 of an hour exposure, so it's not very much light time on this. I didn't have enough red to show it, but these here, the blue parts, are actually kind of reddy, and they're hydrogen 2 areas, and they're star-forming areas. This is also one of the galaxies that they found Cepheid variables in to tell how far away things are. The pulse rate of the variance of the Cepheid is the same by how big it is. And so by checking out these Cepheids, they could tell how bright they really are, and then by how bright they appeared in the galaxy, they could tell how far away it was. So it was very important in our sort of understanding of the way the world goes. This has about, I think, about 10 million stars in it, and that compares to Milky Way with 400 billion stars. So it's pretty small and not easy to see. This is just a comparison example. These are 4-minute shots stretched the same. M51, which is, we can quite easily see with our 8-inch telescope, and there's Bernard's down below. So it's pretty dim.
But actually that galaxy can be seen with large binoculars.
Oh, actually somebody said that one of the things that large binoculars, you see it better than with a telescope. Yeah, that's exactly true. It's quite big across. All right. This is one of the Sharpless nebula, and I took this when the moon was up. These were all taken actually on the same couple of nights when the moon was pretty bright, and it's straight up in Cygnus, and so it's I was trying to stay away from the moon, but after a while I just gave up. And taking pictures of the moon is giving up.
You're just shaming me is what you're doing. You're shaming me.
So I took this. This is actually my telescope hasn't got enough field of view to get. This is actually a mosaic of 6 images.
So is mine.
Yeah. And Paul and I were looking at this with our telescope. This is really good. If you want to find faint nebulas, faint galaxies in the sky, look at the moon first. Works really well. And right down here, which you really can't see in this picture, but there's a really interesting area right there. And in our scope, when you looked at it with the eyepiece, it just jumped right out at you, like that. And it's this hook, just absolutely jumped at you. And and I think it's the edge of Barocius. Is that possibly correct? It's the. I mean, I looked it up on the virtual moon, and that's what it is. Barocius, is that how you say it, right?
Barocius, yeah.
Yeah. So it's the edge. Yeah, it's the edge of that crater. Anyway,
we thought maybe we were the first people to ever see this. And so we thought we should name it. And so we decided to name it McCullough's Hook. So just to be sure that name hadn't been used before, we looked it up on the net, and actually you wouldn't believe what comes up when you type in McCullough's Hook. Anyway, this is a fairly close-in view. I mean, if I just go back one, you can see how much of the image that really is. It's just a little tiny corner of it. All right, next one. Okay. And that's the challenge object. See if you can find that hook on the moon.
What do we win?
That's a good question, Brian. A little star.
The original slide for this said Bob's hook.
No, I don't think that's right.
But wait, yeah, so go ahead and tell your...
No, that's it. I'm done. Just so you can tell when it is, though, this is what you're looking for in the moon. It's past, it's an older moon. Okay, there you go. I think I'm done.
Yeah, so the idea on that challenge is Bob's found something that looks like a hook. All right, so what can you find? What can you find on the moon? Wait till you see what I've got sitting in the can for next month on this. And
does Tim know about this?
Oh, not yet. Not yet.
I'll be on the can.
Okay. All right, thank you, Bob. Excellent. Okay. All right, so just a reminder, the Star Party, so Mike Mulgadam will make the call midday tomorrow, right, for the out by the Diefenbunker. Okay. Heads up, Friday, November 12th will be our annual dinner, and that will be at Algonquin College. Tickets are $40 per person. Luc Simao is he was one of the IYA presenters. There were a number of presenters that were going around to various centers during International Year of Astronomy in 2009. So he'll be coming to speak to us, so that bodes well. All right. So that's just a heads up for that. Starfest, August 12th, 15th. You can still pick up a brochure for that. That's coming up. All right. The annual Ottawa Centre Picnic is coming up at Rolf and Linda Meyer's house. And I'll show you a map in a moment where it is. August 21st and starting around 3 p.m. So there'll be lots of parking right up in their upper field. And so here we go. So there's lots of parking. Good food, which you bring. So bring your own stuff to eat. They'll have, I think you have drinks on hand there, some soft drinks and that. But bring whatever if you care to drink anything else, in moderation, of course. All right. So we've got the world famous museum. You can have a look and see what's inside there. And there'll be telescope observing, so that you can sit there and just observe the telescopes.
Exactly.
Right. That's a little astronomy joke. Yes. Yes. And this the tree bucket. Right.
We've got a siege engine.
Also rocketry. Well, I just found an old astronaut from when my son, I guess Ben he was about only 10 years old, and he had his little rocket that he had made, and the Myers' son, what's that boy's name again? Their son Matthew fitted a rocket engine into the rocket for my son Ben and launched it. Now Ben's rocket doesn't have a nose cone that pops off. And some of these rocket engines that you have, they launch the first charge, burns off, whoosh, launches the rocket. And then after a certain part in the flight, the rocket engine is still burning internally, and then it shoots a charge up the top end, and it blows the nose cone off so that you can parachute down. The problem is, if you don't have a nose cone that detaches, when that second part of the charge goes off, poor old Ben's rocket went to smithereens. But anyway, and I just found that in an old astronaut's. All right, let's go next one. All right, so as you approach their house, we'll have the address in a second on the Upper Dwyer Hill Road. You'll be coming in probably from the Ottawa direction this way. Come into their long laneway going up here, but haul hard right past the wagon wheel. You're going to actually end up going around, behind the trees, and up to the upper field back there, all right? So this is where they be. It's 2572 Upper Dwyer Hill Road, Saturday, August 21st. And it takes about 20 minutes, I guess, to get there from mid Ottawa, I'll say. All right. Another quick heads up: the 24th to the 26th of September on the other side of the river, They're having a very wonderful conference on astronomy for amateur astronomy. All right. Al, do you have any scopes out on loan or any coming back? All right, so if you can see Al Scott, if he's got a telescope, if you remember, you care to rent it out for the month. Stephen McIntyre, are you here, Stephen? Okay.
No word.
No word. Okay. So as I said, the museum's closed, and we're just few minutes over time. All right, but not too bad. And if anybody's going over to Kelsey's, we don't have any coffee fixings out in the flats because Art and Ann are away this month. All right, and the last one. Thanks to Gary Boyle for doing the count again. So 112 of us here, and thank you very much to all of the presenters, and especially to Chris Tarrant and to Bill Wagstaff, who did a lot of the preparation from a distance on this program, and I appreciate the opportunity to chair the meeting for you tonight. All right, Chris, thank you very much.
Thank you, Brian.
All right, safe home. Okay, Tim's gone to see if he can do something about the key. Can we throw the lights up there, please, Estelle? The switch is right there. Last slide. Last slide. Oh, next meeting. Thank you, Chris. Friday, September 10th. Okay, we've got the long weekend, so it'll be the following Friday. So that long weekend, that's the 3-day novel writing weekend. 3-day novel writing. So that, you know what I'm doing on the Saturday, Sunday, and Monday? I'll be writing a novel in 3 days, right? So I'll see you after that.